Hello and welcome to this video in the ARM assembly language programming. In the previous video, we did talk about some of the instructions. We did mention the data processing and data load and store instructions, data moving instructions. In this one, we will talk about the comparison and branch instructions and also code control. So let's go ahead and get started with this. So what I'm going to do here is I'm going to build up on what we covered actually last time. Essentially, we had a message variable last time. It was a tab of ASCII, and it had some message in it. In this case, I'm just going to write, this is my first program. And what I wanted to do is to show you how we can convert this string from lowercase to uppercase letters. So in the previous video, I did show you how to make a pointer that points to the string or to a label in your memory. We loaded a word at a time, and we manipulated that value, stored it back into memory, and I also showed you how to load 1 byte at a time and store it back into a memory. If I remember correctly, we did convert the lowercase h and e into uppercase h and e. We did that kind of manually. We did only twice, but let's see if we can actually write some code that iterates through the string and convert it more or less systematically. Okay, so as you remember, first I need to have a pointer that points to that message. So let's say I'm going to put the address of that label, MSG or message, into R0. So now I have a pointer that points there. And then I want to load a byte from that location into R1 like this. And then I want to convert that into a uppercase by subtracting 20. So if you remember, we did this. We subtract from R1 the immediate value of 20 hex, and then we did an strb to store that value into the same location, and then we updated the pointer. We added 1 to R1, and that way we advanced the pointer by 1. Again, these were the shorthand notations. Again, I can do this as well, and this will still be valid, and whatnot. But going forward, I will use a short notation, but now you know that both of these notations are the same thing. Anyway, what I wanted to do here is I wanted to see if I can actually write a loop that iterates through the string and read one value at a time, convert it to uppercase, and repeat until I reach the end of the string. So instead of doing this manually, I have to basically compare against something. I need to figure out when to terminate that loop. I have to have a loop, figure out when to terminate it, and do some conditions. And based on the condition, I either branch back to the loop or I quit the loop. So the idea here that I want to, let me write this in I'm going to remove those, and I'm just going to write this in sort of like a pseudo explanation of what we're doing. We're going to grab a byte, subtract or check if end, if not, subtract 20 hex, store, repeat. Basically, that's what my loop is going to be doing. So by doing this, we will cover the branching instruction because we have to branch back to the beginning of the loop, and we're going to cover comparisons because we have to compare values to see if we are at the end of the string. Now remember, when we're using the ASCII notation, or when you're using the ASCII directive, the ASCII ends with the null character. So meaning I wanted to check if I reach the end of that string, I have to check to see if I reach the end of I reach the null character. If not, then I'm still within my string. Okay, so I'm pointing to this message, I'm loading 1 byte. So here I need to check. How do I check? Well, there are several ways to do the checking, but one of the simplest way, again, is to use the CMP, which is a comparison. It's a compare. That's the CMP instructions. So I'm going to see if R1 contains the null character. Right? The null character is just 0. It does not mean 0 ASCII or the value 0. It means null. Okay, there's nothing. If that is equal to 0, so if it's equal, I have to quit the loop. So how do I quit the loop? I have to branch out of it. I have to break out of the loop. One way to do that is using the branch instruction. So B is for branch in assembly. And I want to branch if equal to the end or outside of this loop. Okay, but maybe before I do the branch instruction, let me talk a little bit more about this compare. So this compare instruction is basically, like I said, it's a type of instruction. It's a comparison instruction. There's a few of them. This particular one essentially is going to perform a comparison against these two values. You can have two registers. You can have a register and an immediate value. And then it will update the flags in the CPSR. Those flags reflect whether or not, based on this comparison, you got a negative value, you got a 0, you got a carry, and so on. And then those flags can be used to do some sort of a code control, like do I branch, do I not branch, do I add, will the add instruction work, will it not work, and so forth. Again, there is an in-depth discussion on these comparison instructions and whatnot. You can check them out. I'll put a link. There's a pop-up window that will pop up on the top right corner of the video. Check them out if you like. But for now, all you have to know is that this comparison instruction is going to compare R1 against this value. And then based on these results, there are few modifiers, and they allow us, the common ones that we will use are EQ and NE. Those modifiers basically make the instruction execute under two conditions, either if the condition is equal or not equal. There are other ones, there's like greater than, less than, and so forth. But for now, we'll do equal to or not equal. And we can use these modifiers at the end of the instructions in our code to decide whether or not this instruction is going to execute or not. So I'm going to leave that for a second. And here I'm going to write compare R1 against 0. Or 0, which is basically the null character. Okay, so if it's not equal to the null, I have to subtract, right? So again, what was the original code? We were going to subtract from R1 the hex value, the immediate hex value of 20. And because I want this instruction to execute if and only if R1 is not equal to 0, I append the NE next to it. So this makes this instruction execute if and only if R1 is not equal to the null character. And then I'm going to second here. Then I'm going to store str. Remember, we're storing a byte from this register into where the pointer is pointing to. And then I have to update the pointer. So I'm going to add 1 to the pointer. But also, this add should only execute if we did not have the null character. Basically, advance the pointer only if we did not reach the end of the string. So only if not equal. Okay, and then I'm going to repeat. So I'm going to branch back to my loop. This loop does not have to say loop. You can call it whatever you want. It's just a label. I'm going to branch to loop only if, again, the results were not equal. So, by the way, when you use an instruction that compares, or if the flags got updated, they will stay that way until you perform another comparison or you perform another instruction that does update the flags in the CPSR. So that's why I'm able to continue using this NE throughout the next few instructions. Okay, So this is going to basically, again, grab a byte, check to see if you reach the end of the string. If not, subtract 20 hex from it, store it back into that location, update the pointer to the next location, and loop back to the loop, to my loop. So let's see if this works. I'm going to compile and run. I'm gonna step over these instructions. So like again, let me see here. It looks like this is the address of my string. That it's starting at address 20 hex. So if I go to address 20 hex, this is the beginning of my string, right? So this is where it starts. This is my first program, and then it ends here. Next instruction would be to grab a byte from that location. So that's lowercase t, that's 74. I'm going to compare that value, which is 74, against 0. So I'm going to keep track of this CPSR right here. Oops. Kind of the display got all, here we go. So I'm going to keep track of the CPSR value, step over. Notice that the Z flag, which indicates whether or not I have a 0, did not get set. So this subtract should execute, and so on. So if I step over, the subtract did execute, then the store will be executed. So if I go back to memory, the T is now converted into capital T. Step over, we did the add, right? So now we added 1 into R1. Oops, actually I should have added 1 to, my pointer is R0, not R1. Add 1 to R0. Because I looked at this content, I'm like, why did it go to 55? I should be updating this value, not this value. So, all right, let's do it again. So load a byte, compare, subtract if not equal. It worked. Update the pointer if not equal. Now my pointer is pointing to the next location, which is 21. Branch if not equal, back to loop. It did branch to loop, is going to grab the next byte, which is 68. Compare it to null, it's not equal to null. So I subtract 20 from it, it became 48. So this is uppercase H. And then I'm going to write it into memory and so on. I can put a breakpoint here at the branch if not equal. And instead of stepping through all of these instructions over and over again, I can just simply click on continue and it will stop at this breakpoint. So now this allows me to see this sentence being updated from lowercase to uppercase. Oops, I ended up here. S, I, S, M, I, and you can see that this is actually running until the entire string is converted. And then eventually it should not branch back. It's going under, right? So it passed this branch if not equal into the next location in memory. All right, so just a couple things. One is obviously this is not doing a lot of checking. So if you notice that, for example, when I had the space in hex is 20, the ASCII space is actually 20. Again, if I go back to my table and if I look at space, where is space? Space is 20 hex. And when I subtract 20 from it, it becomes 0 or the null character, right? So that's why when you subtract 20 from the spaces after, for example, the word this, you have these zeros, right? So there's a 0 here, there's a 0 here, and so on. And that's why I have these dots, because these dots are basically the null character. They do not have an ASCII equivalent, so that's why you don't see anything here. Obviously, we have to do more checking if we are writing a complete subroutine or program. We would also check not only if we reach the end of the string, but also if the character is an ASCII alphabet, for example, before we can subtract 20. Now let me show you another way to do this, more or less. here I did a comparison, and then all these instructions had to use the modifiers like the subtract, the add, and the branch. There's another way to do this basically. I'm going to branch and link. I'll explain link in a minute. But I'm doing a branch, if not equal, into, for example, another subroutine called update. And here I'm going to use my update. And then I'm going to move these instructions. So I'm going to basically come here, perform the subtract. Now I don't have to worry about adding these modifiers all the time. I'm saying because I have to go and perform these few instructions if this result indicates that I did not reach the end of the string. So I will basically clean up my code a little bit here by doing so. And then I'm going to store this byte. And then I'm going to add 1 to the pointer. Right. So again, I don't have to now use this NE here. And once I'm done from here, I'm going to use something called the link register. So I'm going to move PC, LR. So let me explain this for a second. And then when I come here, branch if not equal, back to loop. And if equal, branch if equal, before we do that, the end. And then maybe you can have the end here, or you can have something else called like next steps or whatnot. So now if it's equal to the end of the string, I'm done. So I branch to the end, which is here. If it's not equal, it will branch back to this loop and repeat. So let me explain this branch and link instruction quickly. You've been introduced to this branch instruction, and you've been introduced also to the branch with the modifier. So this is the branch. This will always unconditionally always branch to loop, no matter what. It will branch indefinitely because there's no conditions, right? And then we added this NE, if not equal, if the two values, or if R1 is not equal to the null character, you branch back to loop. Now, branch and link, what it does is this L that we have basically will set the link register, this link register, with the return address. So basically, once you're done executing these instructions, what happened here is that we're copying the link register back into the program counter, essentially allowing us, once we are done with this instruction with line number 13, the address of this instruction, which is on line 14, will be moved into the program counter, and then the CPU or the microcontroller knows that to execute the instruction at the line 14, not address 14, just this line in this editor, right? So if I compile it, let's go through it and see what happens. So I load the address for my string, load a byte from that string, compare that value into the null character. It is not the null character. Now this branch and link, if not equal, should execute. So I'm going to step into that function and keep an eye on these registers. Okay, so I'm going to step into it. Notice that the link register has been updated and the program counter has been updated, obviously, but the link register has been updated. What is the address of, what value does the link register have? It has the address of the branch of not equal, which was the second instruction or the following instruction after the branch and link. Good. So now once I finish executing, once the program executes these instructions, I'm going to copy that value back into the program counter with this move instruction, and I'm going to come back to my branch if not equal to loop. So if I step over, I subtract, I store the byte, I add 1 to the pointer, and now this link register will be copied to PC. Remember, this link register right here has a value of 10. 10 will be copied into PC. And the CPU knows that it has to go to address 10 to fetch that instruction, which happens to be the branch not equal. So now I step over it. Great. So now program counter is 10, which is referring to this instruction. Now branch if not equal, which was, again, going back through this loop. So if I execute the code, I should see my string being updated from lowercase to uppercase. Oh, I still have the breakpoint here, so I'm going to remove the breakpoint. Continue. This is my first program. Okay, so in this video, in summary, basically, we went over the branch and the conditions briefly, and I showed you how to navigate going and iterating through a loop in assembly. Like I said, there is a full in-depth discussions on these topics. You can check out the other playlists that I have here. And in the next video, we will write a program that basically counts how many characters in a string. And that will be the last tutorial or video in this series. If you're interested, there are other videos that I'm going to be posting that do a few more kind of programs. So if you like this content or if you're interested, follow the channel, hit the like button, subscribe as you like. Thank you for watching, and I'll see you in the next video.